Today we are going to learn the laws of exponents. So as we know, exponents, we have x squared, where x is our base number and that 2 is our exponent. And the exponent tells us how many times we should multiply the base. So we would multiply x times x, which is x squared. So the first law that we see is the zero property of exponents, which states that any number to the 0th power is 1. That seems kind of funny because you'd think any number to the 0th power is 0, but if you look at an example, 10 squared, right, is 100. 10 to the first power is 10. You notice you're dividing by 10 as you go down. And if you follow that pattern, 10 to the 0th, if you divide 10 by 10, well, that gives you 1. So any number to the 0th power is 1. You notice if you have a number in parentheses, that applies the 0 to the whole number, so your answer would still be 1. If you have a number outside of the parentheses that's negative, it's just applying it to the number, and you bring the negative in later, so that's -1. So for example, -5 to the 0th power is going to really say negative and then 5 to the 0th. So you have 5 to the 0th is 1, and that negative is out front, so this answer would be -1. Number 2, -17 is in parentheses, so the 0th power is being applied to all of -17, so your answer is 1. And the third one, negative, this is saying negative and then 2 to the 0th, so this is -1 plus 1, which would give you an answer of 0. So this is 0. The next rule we're going to look at is negative exponents. When we deal with negative exponents, you never want to have a negative exponent in your final answer. You always want it to be positive. So you're going to always try to get a positive exponent. So we're going to go back up to this example of the 10 squared, 10 to the first, 10 to the 0th. If I follow this pattern and I go 10 to the -1st and I have 1, well, to get to the -1st, I divide by 10. So 10 to the -1st is really 1/10. So in order to get this negative exponent into a positive exponent, we would put it as a fraction. If I followed that again, 10 to the -2nd, well, you would have to divide 1/10 again by 10. So if we did that, right, we're saying 1/10 divided by 10 is the same thing as 1/10 times 1/10, which would give you 1/100th, which is the same thing as 1 over 10 squared. So 10 to the -2nd would be 1 over 10 squared, or 1/100th. And then this would be 10 to the first, or 1/10. So anytime we have a negative exponent, we can put it in the denominator, as you see here, and that changes it to the positive exponent. And the reason why that works is shown in this example here. Likewise, if you had the exponent in the denominator that's negative, we can do another example. So if we said we have 1 over 10 to the -2nd, well, we know that 10 to the -2nd is the same thing as 1 over 10 squared, right? Well, this is called a complex fraction. We don't want this fraction in the denominator, so this is the same thing as 1. And then here's our divided by 1 over 10 squared. Because we do not want to divide, again, by a fraction, we can change this to multiplication of the reciprocal. So this is really saying 1 times, and then 10 squared, 1 over 10 squared as the reciprocal is just 10 squared. So 1 times 10 squared is 10 squared. So anytime you have this negative in the denominator, as you see from our example here, in order for it to become a positive exponent, it just flips to the numerator. Similarly, in our previous example, anytime you have n squared in the numerator, like it is here, you just flip it to 1 over that in the denominator, and it's a positive exponent. Okay, so if we look at number 1, b to the negative 8th. Well, this is in the numerator because it's the same thing as saying over 1. So the b to the negative 8th as a positive exponent is 1 over b to the 8th. Number 2, because this is really saying 1 over z to the negative 3rd, or 1 over z cubed, because you don't want this negative in the denominator. To make it a positive, it becomes the numerator, so it's just z cubed. The third example, x squared is already positive. You don't have to do anything with that, but you want to look at this y to the negative 4th. Because this is in the denominator, you want to bring it up. So it's a positive, so you would have x squared is still in the numerator, and then you now have this y to the 4th. The last example, since b to the negative 3rd is in the numerator, but it's a negative, you need to, bring it into the denominator like we see in our example. And because c to the negative 4th is in the denominator and it's negative, it kind of gets flipped up. So these two are kind of changing positions. So we would have c to the 4th over b to the 3rd. All right, next we're going to look at is the product of powers property. So if we look at this, this is saying n to the a times n to the b is equal to the n to the a plus b. Well, why does that work? So let's choose some numbers for a and b. If we said n to the 3rd times n to the 2nd. Well, what do we know about exponents? It tells us how many times we multiply the base. So if I take n cubed is really telling me n times n times n. And then I have multiplication times n squared. Well, n squared we know is n times n. So when we look at this, how many times are we really multiplying n together? We have 1, 2, 3, 4, 5. So we see that n to the 3rd power times n to the 2nd power gives us n to the 5th power. So what we really did, we just added those two exponents together as you see here. Now this only works if we have the same base. So if we have b to the 8th power times b to the 2nd power, that's b to the 8 plus 2, which gives us a total of b to the 10th power. Here, we do not multiply 4 together because 4 is our base. So this is saying 4 squared times 4 squared. So 4 times 4 times 4 times 4. That would be 4 to the 4th power. Because we actually have a number we can evaluate, we would say that this is the same thing as 256. Now for number 3, we have our coefficients. The coefficients come in front of the base number. So if you see 4 and 2, those are our coefficients. We want to multiply those together like normal. So I can say 4 times 2 is 8. And then I can do b to the 3rd times b to the 4th, which would give me b to the 7th. Likewise, for number 4, again, we have our coefficients. So I have 2 and 3 I want to multiply together. And that will give me 6. And then I can deal with my y cubed times y to the 4th, which will give me y to the 7th. All right. Here, 2 is the coefficient. There's really a coefficient of 1 here, so you can say 2 times 1, which will give us just 2 as my coefficient. And then y to the negative 3rd and y to the 9th will give us y to the 6th, because 9 and negative 3 is 6. All right, and the last one, 4 again is our only coefficient, so we have 4. And here we have 2 bases of d and 1 base of n. That n is going to stay by itself because there's nothing I can multiply it with, but I can combine my d to the third and d to the negative eighth. So that will give me d to the negative fifth and then n squared. Well, if we go back and remember that, right, we cannot have negative exponents in our final answer, I know I need to rewrite this. So instead of having d to the negative fifth, I can put that in the denominator as d to the fifth. The 4 does not come with it because, again, this is a coefficient. It really has an exponent of 1 because 4 to the first is 4. So the 4 stays in the numerator because it has that positive exponent, and so does the n squared. So our final answer would be 4n squared over d to the fifth power. This concludes the first part of the notes. Once this video ends, please open up the second part of the notes.